Okay, welcome. We're going to be looking at the last three examples of the washer method notes, example 6, 7, and 8. Starting example 6 says find the volume of the solid generated by rotating the region bounded by y equals 4, y equals x squared, and x equals 0 about the line x equals negative 2. Okay, so x equals negative 2. Oops. Is our axis of revolution. So let's make sure that we label that. Oops, x equals negative 2. Okay, so then we need to find our big R, little r, area, the volume of a slice, and the volume of our whole solid. Okay, so big R goes from our center, from our axis of revolution, all the way out to the outside of our figure. Okay, so these are going to be, because that vertical axis of revolution, these are going to be dy slices. So we're going to need our equations x in terms of y. Okay, that guy is the right side of that parabola. So I'm going to come over here to this y equals x squared and square root both sides to get that x by itself. And we get root y. We're in the first quadrant there, so we're looking at the positive root y there. So this is x equals root y. All right, so capital R is going to be outside minus inside. So root y minus, and then the inside is at x equals negative 2. So minus negative 2. So that'll give us root y plus 2 for our big R. All right, for our little r, we're going again from the center, which is our axis of revolution, to the inside of our solid. So this is our little r. And again, a dy strip, and little r is going to be determined by, again, you can think about it as outside minus inside, even though we're looking at the inside surface of our solid. So right minus left. So that right side is the y-axis, right? X equals 0 is how they give it to us here. So 0 minus the left side, which is x minus 2. So 0 minus a negative 2 equals positive 2. And it's just a constant positive 2. So again, picture anytime you draw that inner radius, any of these inner rectangles are always going to be the same. They're always going to have that height of 2. So we're cutting out that inner circle is always have a radius of 2, or if you're thinking about the inner cylinder, the core of our solid always has that radius of 2 that we're drilling out or cutting out or whatever. All right, so area is big R squared minus little r squared. So our big R is root y plus 2. We want to square that and subtract our little r, which is 2, and square that. Okay, so the volume of a slice is pi times that difference we just found. So root y plus 2 squared minus, and 2 squared is just 4, times our height, which is dy. We're doing dy slices in this one. Okay, so there's the volume of a single slice, and to get the volume of our whole solid, we're going to integrate. We're going to factor out that pi to the front, and we're going from our interval is bottom to top, so we're looking for C and D values. Okay, so our lowest point is at the origin, 0, 0, so we're going from 0 up to our highest point. That's the line y equals 4, which we're told in our directions there. So we're going up from 0 to 4. There's our C and D values. All right, so we've got on the inside capital R, squared, minus little r squared, And again, be real careful about how you put this in your calculator. Make sure your parentheses are as they should be, and your exponents and all that jazz. All right, so when you do so, run it to the nearest thousandth. We should get 92.153. Awesome. All right, next up, example 7. Find the volume of the solid generated by rotating the region bounded by y equals 2 root x, y equals 4, and x equals 0 about the line x equals 4. Okay, so there's our axis of revolution, the line x equals 4. Back to a horizontal axis of revolution. Make sure that you label it. On your diagram. Please, 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 please label it on your diagram. Oops. Wrong button. Alright, so let's look at our diagram here. Okay, we need our big R. We need our little r. Area. Volume of a slice. And then we'll do volume of a solid to the right when we have more space. Alright, big R. Our axis of revolution is on the top this time. Okay, so interesting. So, wait. No. I just highlighted the wrong line of revolution. I highlighted y equals 4. Come on, Mr. Flory. I was testing you. How many of you noticed? Did you notice? Did you notice? That was a test. That was a test. I did that on purpose. Totally on purpose. Alright, there's our line. X equals 4. That is our axis of revolution. So if it was y equals 4 like I originally put, we wouldn't have to do the washer method. We could do the disk method because it would be totally attached to that. But now it's not. So we gotta do the washer method. Alright, so but it's on the right side instead of the left, or instead of on the bottom. So let's see what happens here. It is still a vertical one. So for our big R, again, we're going to follow this pattern of doing from the center to the outside of that. Again, whether you visualize it as a circle or as a cylinder or as a washer, a slice, whatever. The width is dy. And we still want to go right minus left. Because we're squaring it, you could do left minus right. It's not a big deal. But keeping with that pattern of right minus left, our right is 4, and our left is 0. Right? So this x equals 0 line here determines our left side. So our big R is just going to be 4. Our little r is what changes depending on where we are, though. Okay, so here's our little r. And it's determined, again, right minus left, so 4 minus, and then this curve here, what is that curve? 2 root x. Alright, but that's y in terms of x. We've got dy strips, so we want to solve for x. So I'm going to divide by 2. And then I'm going to square both sides to get that x by itself. So now we've got y squared over 4. So x equals y squared over 4. That is our curve there. So I'm going to jot that down. X equals y squared over 4. Okay, or 1/4 y squared, whatever. So that's what we're going to subtract. That's that left part of our curve there. Alright, so that's our little r. Okay, so area is big R squared minus little r squared. So big R squared, 4 squared, minus little r squared. Make sure you put that in parentheses when it's got more than one term. Gotta put it in parentheses. Okay, so volume of a slice. We have pi. Don't forget the pi. Times what we just found, our area. 4 squared is 16. All right, remember that binomial squared, you can't just distribute that square to each of those terms. That's going to be a trinomial. So play it safe, just leave it like that, put it in your calculator like that. All right, we've got dy strips. Oops. All right, so let's find the volume of the whole shebang here. All right, so volume of our solid. We've got pi times the integral. And what's our interval going to be? We're going from bottom to top. All right, so it's looking like 0 to 4. Let's see, this function is y squared over 4. So if we plugged in a 0, we would get 0. Yeah, so 0 to 4 is our c to d interval. And let's put our difference of our squares on the inside. And if you put that in your calculator, round to the nearest thousandth, we should get 93.829 for the volume of that solid of revolution. All right, beautiful. All right, next up. Number 8. This one's got multiple parts, one diagram. It says, let capital R be the region. Ooh, be careful. We've been using capital R for a radius, so we've got to be careful about our variables here. Let capital R be the region bounded by the graphs of y equals 2x squared, y equals 0, and x equals 2. Okay, they've already drawn it for us. They've already shaded it for us. We're in the first quadrant. We've got a parabola. We've got a vertical line and our x-axis bounding our region. All right, so A says let the volume of the solid, find the volume of the solid generated by revolving the region R about the x-axis. Okay, so I'm gonna be writing with my pen that I can erase for each of these parts. So if you're working in your notes, maybe writing pencil, or if you want to redraw the diagram multiple times for each of these, you might need to, or just whatever works for you. Just know I'm going to be erasing and redrawing on the same diagram. All right, so here's our axis of revolution. Which is our x-axis, y equals 0. Okay, so we're revolving that whole thing around there. Now, that whole region is bound to that axis of revolution, okay, from 0 to 2. So I don't need to use a washer method. I can go back to the disk method. Okay, do you guys remember the disk method? All right, so this was the one, and here's just gonna be the challenging part going forward is number 1, determining which method to use on these problems, and then number 2, make sure you're associating the right formula for each one. All right, for this one, same as our washer method, but notice we're not cutting out the inner circle, the inner region. So it's just big R squared, or just that outer outside height squared. Okay, inside of our integral. Okay, so I'm gonna draw my. Ooh, let's try that again. I'm gonna draw example rectangle. This is going to be a dx slice, and our big R is determined by top minus bottom. Our top is at 2x squared. Our bottom is 0. Okay, so volume of a slice is pi times big R squared, so 2x squared times our thickness of dy, or excuse me, dx. So the volume of our whole solid, again using the disk method on this one, is our integral. Let's see, our pi is out front. Our interval is from 0 to 2. And let's see, if we square that, we get 4x to the 4th All right, putting that in our calcs, rounding to the nearest thousandth, we get 80.425. Awesome. All right, part B says find the volume of the solid generated by revolving the region R about the y-axis. All right, so I'm gonna do a little bit of erasing here. Okay, so about the y-axis, that's this guy here. Let's make sure we label that. So this is axis of revolution, which is x equals 0. Okay, so do we need to use the disk method or the washer method for this one? Well, it's not attached to our axis of revolution, so we're going to need to use the washer method and find both an outside and an inside. Okay, so big R, little r, area, volume of a slice, and then eventually volume of our solid. Okay, again, I like this because it sets up a little structure. We know it reminds me of what I need to find in order to essentially build that integral at the end there. All right, so big R. We've got dy slices, so we're going to need to find this equation in terms of x. All right, so let's see. If I come over here, y equals 2x squared. If I get that x by itself, I'm going to divide both sides by 2. And then square root both sides. We're in the first quadrant, so we're dealing with a positive square root of y over 2. All right, and I'm going to leave it just like that. I don't need to rationalize that since we're going to be using our calculator to get a rounded answer at the end. Okay, so big R, we actually don't need that for big R. Big R goes from x equals 2 back to x equals 0. So 2 minus 0 is 2 for our inside. For our little r, though, we are going to need that because our little r is determined by that curve. And so we've got root y over 2 minus our inside, which is x equals 0. Okay, so area is big R squared minus little r squared. And so 2 squared minus square root of y over 2 squared. So that's just going to give us y over 2. So when we find the volume of our slice, we've got pi times 2 squared, which is 4, minus square root squared undoes each other. Boom. Times dy for our thickness. Okay, volume of our solid, pi times our integral. Again, we're going from bottom to top, so we're going from 0 all the way up to, it looks like it intersects at 8. Let's see, that's the equation x equals 2 and y equals 2x squared. Okay, or we got, what do we get? Square root of y over 2. So if I plug in an 8 for that y, does that give us a true equation? 8 over 2 is 4, square root of 4 is 2. Yeah, looks good. All right, so we're going from 0 to 8. And what do we got here? 4 minus y over 2. With respect to y, plug that into your calc. You should get 50.265. All right, nice. So it definitely makes a difference where our axis of revolution is. Notice that these two areas are very different. Or volumes, excuse me, are very different. Okay, part C. Find the volume of the solid generated by revolving the region R about the line y equals 8. Ooh, okay, so I need to do some more erasing. All right, y equals 8. That's this guy right here. All right, horizontal line, y equals 8. Okay, so we are revolving about that. So let's see, if we draw our region is not connected for the whole interval, so we're going to need to do washer method again. So determine which method to use. I'll draw my big R, which again goes from that center, from that axis of revolution, all the way to the outside of our region. So that's big R. And that's a DX strip. And little r goes to the inside.
Mr. Flory?
Oh, hold on just a second. Okay, so capital R, if we go top minus bottom, oops, then top is that y equals 8, minus the bottom is y equals 0. It's going to be a solid 8, little r. Top minus bottom is going to be 8 minus, and then this curve here is from that y equals 2x squared. So there's our little r. Okay, so for our area, we're going to square our big R minus the square of the little r. And for the volume of our slice, multiply that by pi. Let's see, I need to be careful there. Alright, we did 8 minus 2x squared times our thickness, which is dx. Alright, and then the volume of our solid, if we integrate that from 0 to 2, with respect to x, then we should get 187.658 as our volume. Whoa there, puppy. Come back. Awesome. Alright, one more section. Okay, last one, part D says find the volume of the solid generated by revolving the region R about the line x equals 2. Okay, so I'm going to need to erase some more. Oops. I don't want to erase that. Alright, so it says the line x equals 2. So we've already got that there. So let's highlight that. X equals 2 is that vertical line. And let's see, we'll use a color we haven't used yet. Here's our axis of revolution. And that is x equals 2. Alright, so which method are we going to need to use on this one? Okay, so between disk and washer, we got to say, is our solid stuck to the axis of revolution connected for the whole ride? And yeah, it is on this one. So we can use the disk method. Okay, so from there, we're going to draw our rectangle example. These are going to be dy slices. And if we go right minus left for our capital R, the right is that x equals 2. The left side is this function here. Alright, since we're doing dy slices, we're going to need it in the x equals form. So we're going to use that x equals root y over 2. Alright, so volume of... if we jump straight to volume of our solid, we've got pi times our integral. We're going from bottom to top again, so 0 to 8. Okay, this one's just r squared, right, for disk method. So in parentheses, 2 minus root y over 2 quantity squared with respect to y. Put that in our calcs. 16.755 rounded to the nearest thousands. All right, hopefully that's helpful. Make sure you practice the washer method homework sheet, and we will tack on another method for volumes of solid revolution tomorrow. See you then.